Today we are going to discuss a new chapter on effective stress. This is very important. Actually, it is required in a way calculation of the geotechnical engineering. We have to find out the total stress, effective stress, etc. So that this is a very important chapter for the geotechnical engineering. So after completion of the chapter, you will be able to calculate. They will find out the total stress, pore water pressure, and the pore pressure and the effective stress on the soil. Now, what is the total stress? Now, the total stress. Let me go to the next slide. Let me draw a diagram. Suppose now there is a soil. Sorry, this is a soil. Now, at this level, we want to find out what is the at this level there is this element, and we want to find out what is the stress acting on the element. Now, what are the stress acting on the element? That is the whatever the pressure given by the soil above it, soil mass above it, whatever the pressure given by the soil mass above it, and that is the stress acting at this level. Now this stress, this whatever the stress of the soil acting above this line, any point, say that there is another point somewhere here, and we want to find out. Then the whatever the stress given by the soil above it. Soil above it means this portion of the soil mass which is above this one. The whatever the stress given by that one, that is the total stress. So at this point, if you want to find out the total stress, what is that one? It is the uh, this is the portion of the soil above this one. Say that this depth is h, for so that this soil, whatever the stress given by the whatever the pressure given by the this soil mass, then that is called the total stress acting on this line. Can you understand? So at any level we can find out, what is the total stress. At any level we can determine. Say there is a in this one there is a line. This is ground surface, and at this depth we want to find out what is the total stress. So from that one, what is the depth? This depth is the h. Say that this depth is the h. So that means we want to find out whatever the stress given by the this portion of the soil, that is the from the ground surface to the this portion of the soil, whatever the stress given by that one on this line, that is the total stress acting on the line. So this is the stress given by the this portion on this line, and that is the total stress. Now how to determine? It is the for finding out this one, what is the stress, how much the stress is given by the this portion of the soil, whatever the weight of the soil over here, whatever the weight of the soil in this portion of the soil, and that is the stress on this line. So what is this weight? This, if the gamma is the bulk density of the soil mass, then the what is the weight up to this point? Weight up to this point is the gamma into this, weight up to this point is the gamma into h. So for that is the total stress acting on this line. So the what is the total stress? It is the stress given by the soil. It is the stress given by the soil on soil above any section. There is any section you consider. So if you want to consider the somewhere here, then whatever the stress given by the soil above it, say that this depth is the h1. So whatever the stress given by the soil above it, that is the total stress. That is the total stress. And how much is this one? That is nothing but the weight of the soil. Weight of the soil. So how to find out the weight? We know the gamma, that is the bulk density of the soil mass is known, and we know what is the depth of the section. This section is at a depth of h1, so we know the depth of the section. So the gamma into h1, that will give you the total stress at this level. Suppose at this level, if you want to find out, say that this is the level at this one you want to find out, then what, say that this depth is h2, this depth is h2, then at this level, how to find out? This is the stress on this portion. That means what is the stress in this one? That is nothing but the weight of the soil above it. That means from this point to this point, whatever the weight of the soil, weight of the soil above it is called the total stress acting over this section. And how much it is this one? That is the gamma is the unit weight of the soil, and h2 is the depth of the soil. So the gamma into h2, that will give you the stress acting on this one. Actually, it is the gamma into volume. Volume is how much? It is the gamma into h2 into 1. Width is 1, and this length is also 1. That means we have to consider the unit length and the unit width only the depth is the H2. So that's why it is gamma into H2. It is not the gamma into H2. Actually, the total weight of the soil uh, at depth AA. Say that this section is the AA. At depth AA is equal to, what is that one? That is equal to gamma, that is the unit weight of the soil, into the width of the soil, length of the soil, and the depth of the soil. So that one, so it is gamma into H2. So what is gamma? Gamma is the bulk density of the, it is the bulk bulk density of the soil mass, and H2 is the depth of the section AA. So from that one we can find out what is the total stress. So that total stress is the, it is the stress of the soil mass. One thing you remember, this is the stress given by the soil mass on any section. What is the stress over there? There is a, it is nothing but the weight of the soil above the soil mass. So from that one we can say that this is the total stress, that is the total stress of the soil element. There are two types of the total stress. One is the, there are two different types of the total stress. One is the this one, take another slide. So that there are two types. So the one is the overburden pressure, and another one is the one is the overburden pressure, and another one is the stress increment. Now, what is the overburden pressure? This is, suppose this is the this is the soil, and this is the soil ground surface, and we have considered a section AA at a depth of H2, at a depth of H2. Now, the overburden pressure is the pressure given by the soil above the section AA, that is called the overburden pressure. That is the, what is that one? It is the stress given by the portion of the soil above the section AA. What is this one? So the, how much is the overburden pressure? That is equal to, if the gamma is the unit weight of the soil, then the gamma into H2 is the overburden pressure acting at the this one. That is nothing but the overburden pressure is nothing but the it is the overburden pressure. Overburden pressure is the pressure given by the, that is the, it is the stress given by soil above any section, and soil above any section. Above any section, that is any section means we have considered the section AA. So whatever the stress given by the soil above any section, that is called the, that one is called the overburden pressure. So how to find out? That is the unit weight of the soil multiplied by the depth of the section. Depth of the section in this point is the H2. So from that one we can calculate what is the overburden pressure. Now if we apply a load here, suppose if we have constructed a footing over there, then this will be acting as the stress, additional stress over the overburden pressure, and that is called the stress increment. That is, if we apply any external load on the soil surface, then that load will act as the additional load. That means this will act as the additional stress over this portion, and that is, that one is, that stress is called the stress increment. So can you understand the difference? In case of the overburden pressure, it is the weight of the soil above any section, that is the overburden pressure. It is the only the soil weight is taken into consideration. But in case of the stress increment, if we know stress increment means if we place a footing, or if we are apply any additional load at the ground surface, then the stress due to that one at the level AA, that is called the stress increment. So there is a basic difference. In one case we do not consider any external load, we consider only whatever the weight of the soil above any section, that is the overburden pressure. And in second case, in case of the stress increment, it is the stress given by the soil, stress acting on the line AA, given by the soil, by the additional load which is placed on the ground surface. So this is an additional load. If we place a footing or something on the ground surface, then that will give the one additional stress on the soil mass at the level of the AA, and that is called the stress increment. So the stress increment is due to the additional load. That is the some man-made structure or the something is there on the ground surface, then the load given by that one, that is the stress given by that one, is called the in stress increment. And the stress given by the soil above any section, not any additional stress, without considering any additional stress, that is called the overburden pressure. So that is the difference between the overburden pressure and the one term is the overburden pressure, one is the overburden pressure, that is the given overburden pressure, and another is the stress increment. Stress increment, there is the stress given by the it is a stress given by this by this by the construction of the any additional load. That is, it is the construction of the any structure like the footing of the foundation or something. If we construct, then that will give you one additional stress, that is called the stress increment. So that is the difference, and the in both are the fall in the category of the total stress. Total stress is the stress given by the soil above the any section, or if we consider the stress increment is the stress given by the additional load placed on the ground surface. So that is called the stress increment. And there is a basic difference is that in one case we do not consider any additional stress, that is the overburden pressure, and when you consider some additional stress, that is the stress increment. Now, there is another term called the pore pressure or the neutral stress. Now, let me go to the next slide. Now, suppose this is the soil mass. So, let us consider. We know the soil is a three-phase system. So, in this one portion is the air, one portion is the water, air, water, and the soil solid. So, in the ground, it is like this. These are the soil grains. These are the soil grains, and there is some void in between, and these voids are filled with water. So it is like this. Now there are some soil grains. These are the soil. These are the soil grains. These are the soil. All are the soil grains, and these are the voids, and the voids are filled with the water. Now, when you give any stress, it may be overburden stress or it may be the stress increment. When you give any stress, then the this water, these voids which are filled with the air or the water, that air will automatically go out from the void when we apply any additional stress. That is, these are the stress applied, the overburden stress applied. So then the whatever the water air present within the void, that will automatically go out from the void. But the water, whatever the water present, that will take lot of time to go out from the void, and it depends on the permeability of the soil. If the soil is very permeable, in that case the water will immediately go out from the void, and if the soil is not permeable, then in that case it will take lot of time to go out from the void. Now if the water remain within the void, and if we apply the stress, what will happen to the water? Say this is the water molecule, then there will be hydrostatic pressure. Water will act as the hydrostatic, give some hydrostatic force. What is the hydrostatic force? There is the one drop of the water is giving equal stress in all the directions. So the whatever the water present over here, that will give some hydrostatic force in all directions, and that hydrostatic force given by the water is called the pore pressure or the neutral stress. That is, if we apply any compressive stress in the soil, then in that case what will happen? So if we go to the next slide, so that this is the soil, and if we apply some compressive stress over here, then what will happen to the water over there? These are the water particles that will give stress in all the directions. It will give the hydrostatic stress in all the directions. That means this is the water particle, so this will give the hydrostatic stress in all the direction. That is, the water particle will give like this hydrostatic stress on all the directions, and that hydrostatic stress given by the water is called the neutral stress or the pore water pressure. Can you understand? So there are two terms. One, we have learned about the total stress, that is the stress given by the soil above any section, the soil mass above any section, that is called the total stress. And if we consider the water present within the void, then that water will when we apply the compressive stress on the soil, that compressive stress may be the overburden pressure, or that may be this stress increment, but due to this one compressive stress, the water will give some hydrostatic stress to oppose that one. Otherwise, what will happen? The water has to squeeze. The water wants to squeeze, but to prevent the squeezing of the water, what will happen? It will give some resistance, and that resistance is nothing but the hydrostatic stress, and that hydrostatic stress is called the pore water pressure, or the neutral stress acting on the soil mass. That is the neutral stress acting on the soil mass. Can you understand? So there are these two terms, and there is another term is called the effective stress. What is the effective stress? Now, so that this is the soil grains. These are the soil grains. These are the soil grains, and this is the water present. This portion is the water present within the soil mass. Now, due to the application of the stress, the stress is applied in this direction, and the hydrostatic force will act in this direction. This will act in the opposite to this one, which prevents the squeezing of the water. Now, and this stress is acting on this soil particle also. Then the soil solid also, this will act on the soil solid, and that whatever the weight of the soil, whatever the stress given by the soil solid in the downward direction, that is called the total effective stress. That means it is the stress given by the soil particle, that is the soil solid, in the downward direction, that is called the soil that one is the effective stress. So if we consider a section over here, if we consider a section over here, there is a section AA, then in that case this is a soil particle. So when we apply the stress here, this soil particle will also apply some stress in the downward direction, and the stress given by the soil particle in the downward direction, that stress is called the effective stress. That means effective stress is nothing. So the grains are like this. This is one grain, this is another grain, this is another grain, this is another grain, this is another. When you apply the load over here, this will give the load stress to the there, this will give the stress here, this will transfer the stress over here. So in this way, the stresses are transferred from one grain to the other, and that is called the intergranular stress, and that is nothing but the effective stress. That is the stress given by the soil grain to the to any section or to the other grain, then that stress is called the effective stress. Can you understand? So there are three terms. One is the total stress. When you consider the stress given by the soil mass. Soil mass means it is the stress given by the soil solid as well as the stress given by the water, that is called the soil mass, and the stress given by that one is called the total stress. Now the second one is the pore water pressure or the neutral stress. In the neutral stress, whatever the stress given by the if we apply the compressive stress to this one, so that compressive stress will act on the water present within the void, and it wants to squeeze the water, but the water is incompressible, so the water will resist that one by applying some hydrostatic stress in the opposite direction. So that hydrostatic stress is called the neutral stress or the pore water pressure. And the stress given by the soil grain to the other grains, that is called the effective stress or the intergranular stresses. So the stress given by the soil grain to the other other soil grains, then that is called this. So here in this diagram, if you see in this diagram, if you see in this diagram, if you see in this diagram, so these are the stresses between the grains, and that is called the effective stress. This is the stresses given by the soil above that one, that is the total stress, and this is the water present within the void, so that will act in the opposite to the total stress. So that is called that stress is called the hydrostatic stress, and that is the neutral stress or the pore water pressure. That is the hydrostatic force, and that is the nothing but the neutral stress or the pore water pressure. Now if we want to find out the relationship between the total stress, effective stress, and the pore water pressure, so let me go to another slide. Now in this one, here you see that this is the soil. say that there is a soil mass at this level, we want to find out what is at the level of the AA, we want to find out what is the stress. Now the soil grains are like this. These are the soil grains. So all these are the soil grains. These are soil grains. All are the soil grains. Now, when we want to find out the total stress, what is the total stress? Total stress at AA, that is equal to how much? It is the load. It is the stress given by the this soil mass above the line AA. This is the line AA. So the stress given by the soil mass above the line AA, that is called the total stress. Now the how to find out? We know the unit weight of the soil, and we also know what is the depth of this one. So it is H. So from that one, the total stress is equal to gamma into H. So from that one, we can calculate what is the total stress. That is the stress given by the soil mass. Soil mass means it comprises of the soil grain as well as the void. The void may be partially filled with water and the partially filled with the air. So the soil may be saturated or may be unsaturated. So the voids are present. If the water is present, then the water will go out when you apply the load. And if the air is present, then the air will go out when you apply the load. And if the water is present, then that will remain within the void. And so the stress given by the soil and the water, that on the line AA, that is called the total stress. Now the next one is the pore pressure. What is the pore pressure? The pore pressure is the pore pressure, or it is also called the pore water pressure, or it is also called the neutral stress. Now when we apply the load, so that whatever the water present here, so that will give some hydrostatic force in all the directions. That will give some hydrostatic force in the upward as well as in the downward direction. So these are the hydrostatic force given by the water in the upward direction as well as in the downward direction. So this downward hydrostatic force will act as the additional stress over the line AA, and that is called the pore pressure, and that is given by the how to find out that one? That we have to find out by the gamma W into H. Within the depth, whatever the water present, so that we have to take into consideration. So we have to, gamma W is the unit weight of the water multiplied by the H, depth of the water. Depth of the water is how much? From this point to this point. This is the water table is somewhere here. So from this point to this point, the water is there within the void, and that will act as the hydrostatic force, and some portion of the hydrostatic force will act in the downward direction, and that will be the act as the pore pressure over this one. So that is the pore pressure. Then the next one is the effective stress. Next one is the effective stress. Now what is the effective stress? Effective stress is the stress given by the soil grain. That means it is the stress given by the soil grain. That means these are the soil grain present. These are the soil grains. So whatever the stress given by these soil grains on the line AA, that is called the effective stress. Now how to find out that one? We know the total stress. That is what is the stress given by the soil mass, that is known. And another thing we know, what is the pore pressure? That is what is the pore pressure? The hydrostatic stress acting at the void, which are filled with the water. So whatever the hydrostatic force stress acting on the void, within the void, which are filled with the water, that stress also we know. So from that one, so this stress is acting, some portion of the hydrostatic stress is acting in the downward direction. This is the some portion of the hydrostatic stress is acting in the downward direction, some portion is acting in this direction, and some portion is acting in the upward direction. So this upward stress will reduce the weight of the soil. It will reduce the weight of the soil, this soil mass. So if we want to know the total stress, So from that one, total stress, if we subtract the hydrostatic stress, that is the pore water pressure, then we can find out the effective stress. So that it is the pore water pressure, and which is acting in the downward as well as upward direction. So upward means it is trying to reduce the weight of the soil solid. So that's why the total stress minus the whatever the stress given by the water, there if we take out that one, then the only the stress given by the soil grain will remain, and that is the effective stress. According to the definition of the effective stress, whatever the stress given by the soil grain on any this one, that stress is called the effective stress. And the how to find out, it is the stress given by the soil mass is the total stress, and from this total stress, if we take out the hydrostatic stress, then that means the pore water pressure, then we can find out what is the stress given by the soil grain. That means water is taken out, the stress given by the water is taken out, then only we can find out what is the stress given by the soil grain. So from that one, we can find out the effective stress is equal to total stress minus the pore water pressure. So we can write down the total stress is equal to effective stress minus the total stress is equal to, so effective stress minus the pore water pressure, plus the pore water pressure. So the effective stress is equal to total stress minus pore water pressure the pore water pressure, and that is called the effective stress. So what we have to find out? First we have to find out what is the total weight of the soil mass. Soil mass comprises of the soil and soil grain and the water. So that we have to find out the total stress, and then from that one we have to find out the hydrostatic stress. Hydrostatic stress is the pore water pressure, whatever the water present within the void, that will give some stress. When you want to switch that one, that will oppose that one, and that stress is called the hydrostatic stress, and that one is the pore water pressure. So from the total stress, if you take out the pore water pressure, so the water has gone from that one, the stress given by the water has gone, then only the stress given by the soil grain will remain, and that is called the effective stress. Can you understand? So there are three terms is the total stress, pore water pressure, and the effective stress. The effective stress is equal to total stress minus the pore water pressure. Now let us calculate. Let us calculate this. Suppose there is a dry soil. Now that there is a soil, dry soil. There is no there is no water present, and the unit weight of this one is the gamma d. Now at this level, at the level AA, we want to find out what is the stress, what is the total stress, what is the pore water pressure, and this depth is the H, is the depth of the soil mass, that is the depth of the soil mass of this one. So what is the total stress at this level, at the surface, at the level, say it is B, at the level BB, what is the total stress? Total stress at BB is equal to how much? This is the top of the soil surface. This is the top of this one. This one is the top. This one is the top of this one. So there is no soil above this one. So what is the total stress over here? What is the definition of the total stress? It is the weight of the soil above any section. It is the weight of the soil mass above any section, that is called the total stress. So at the BB, what is the total stress? You tell me. What is the total stress at the BB? 0, because there is no soil above that one. So the total stress at the BB is the 0. Now what is the pore water pressure? Pore water pressure. There is no water present over there, so the pore water pressure is also 0, because there is no water present over here. So it is the dry soil, so there is no water present, so the pore water pressure is also 0. Then what is the effective stress? What is the effective stress? That is equal to the total stress minus the pore water pressure, so the effective stress is also equal to 0. Now at the AA, now you come to the at AA. Now at this level, what is the total stress? Total stress. Total stress, how to find out? That is the unit weight of the soil mass multiplied by the depth of the soil mass. That will give you the total stress. So what is the unit weight of the soil mass? That is the gamma D is the unit weight of the soil mass. And what is the depth of the soil mass? Depth of the soil mass is the H. So that is the nothing but the total stress. Total stress at the level of the AA is nothing but the gamma D. That is the unit weight of the soil mass multiplied by the H. Now the what is the pore water pressure? Pore water pressure. What is pore water pressure? How much is the pore water pressure? Because the soil is dry, so no water is present there. So the pore water pressure is equal to 0. And now the what is the effective stress? Effective stress, that is equal to total stress. Total stress is how much? Gamma D into H minus the pore water pressure, that is the 0. So it is equal to gamma D into H. Gamma D into H is the, this one is the, like this. So from that one we can find out. Let me take so let me draw the diagram. So now, so the here this is our soil. This is our soil grain, soil like this, dry soil. This depth is how much? This depth is the H. H is the depth. A is the this one, and the B is surface. So the at the surface, what is the total stress? Total stress at the surface is the 0. Now at the depth of the AA, what is the total stress? Total stress is the gamma D. So the gamma D is the total stress at the depth. This one. And how it varies? Here it is 0. It is here it is at in gamma D. It varies as the in the triangular fashion, because at every point it will increase. As the depth increases, total stress increases. So the total stress will become equal to gamma D into H at a depth of H. Now the pore water pressure. At the top, what is the pore water pressure? Is 0. At the bottom, the pore water pressure is 0. So there is nothing liquid on the vertical line. So the pore water pressure is equal to 0. Now the next one is the effective stress. At the top, the effective stress is 0. And at the bottom, what is the effective stress? At the bottom is the gamma D into H. So the effective stress at the bottom. And if you join, it varies like this. It varies gradually. That is, it is increasing gradually. So it is gamma D into H. So in this way, we can draw, this is the total stress diagram. This diagram is the total stress diagram. This diagram is the pore water pressure diagram, and this one is the effective stress diagram. So from in this way, we can draw the diagram of the stress distribution for the dry soil. Now let us go to the second one, the effective stress on the free water. There is only water, there is no soil present. So let us draw the diagram. Now this is the only water is there, there is no soil, and this depth is how much? This depth is H. Depth, let us take this is A and this is B. Okay, now let us find out the total at AA. At AA, what is the total stress? That is equal to, what is the at AA? At the, it is at the top of the this one, there is no soil water above this one. Here there is no soil, only water is present. Let us consider a container where the water is present, and we want to find out what is the total stress, effective stress, and the pore water pressure. Now at the top of this one, there this is the top surface. This one is the top surface. This one is the top surface. So at this point, what is the total stress? The total, there is no water above this one, so this is the top surface. The total stress is equal to 0. And at this point, what is the total stress? How much? At this point, it is what is the definition of the total stress? It is the stress given by the soil and the soil mass. Soil mass means soil and the water. Now here there is no soil, so there is only water. So what is the total stress at the BB? There is a stress given by the water only. There is no soil present, so it is the stress given by the water only. So let us write down first. So the total stress at the point AA is equal to how much? It is equal to how much? It is equal to 0. Total stress at the point is equal to 0. And then pore water pressure at AA, how much? It is the top of the water surface. At the surface, there is no water present above that one, so the pore water pressure is also equal to 0. So the effective stress is how much? Effective stress, that is, what is the effective stress? That is equal to total stress minus pore water pressure, so it is also 0. So at the level AA, at the top surface, there is no total stress, no effective stress, no pore water pressure. At BB, total stress is how much? Total stress, how much? What is the total stress at the BB? Now the unit to it is the gamma W. Now there is no water present, so whatever the soil, where the stress given by the water above this one, that is the total stress. So the how much? It is the gamma W into H, unit weight of the water, into the depth of the water. Depth of the water is how much? It is H. There is no soil present, so that's why we have multiplied the gamma W by the H. Okay. Now what is the effective stress? What is the pore pressure? Pore water pressure. Pore water pressure is how much? At the depth of H. What is the pore water pressure at BB? How much? Gamma W into H, that is the pore water pressure at the BB. Then we find out what is the effective stress. Effective stress is equal to total stress minus pore water pressure, so it is equal to 0. So at the top also the total stress, effective stress is 0. At the bottom also effective stress is 0, and the total stress at the top is 0, and it varies gradually up to the depth H, and at a depth of H, the total stress is equal to gamma W into H. The pore water pressure is also equal to gamma W into H. Why? Because there is no soil present, only water is present. So from that one we can find out. And if we draw the diagram, yes, no, there is no water. AA is the top point, no? The second one I have given the AA at the top. So at the top, at AA, there is no water above that one. This is the water surface. So it is at this one. So there is no water above it one. So the stress is 0. Can you understand? Solidus. Yeah. Okay. Let me draw the diagram. Then I will go to the next one, another one. Then you can understand. Okay. So this is the this one is the, it is water only, we'll do it to the water only, and at this the BB, this is point AA. So the total stress at the point AA is 0. At the point BB is there is some amount of the total stress, so the total stress is like this, and this one is the gamma W into H. So this is total stress diagram. Pore water pressure diagram similar. Total stress at the pore water pressure at the top is 0, and it varies. So this one is the gamma W into H. And the effective stress, effective stress is 0 at the top as well as the bottom. So the effective stress is equal to 0. So this is the diagram for the this stress given by the free water. It is the stress given by the free water, that is like this. So this is the total stress diagram. The first one is the total stress diagram, total stress. Next one is the pore water pressure diagram, and the third one is the effective stress diagram. Why the effective stress is 0? because the difference between the pore water pressure, total stress and effective pore water pressure, uh, it is zero everywhere. So that's why the effective stress is zero everywhere. Can you understand? So this is like this. Now let us consider slightly different. Slightly different. Now the soil and the water. Initially we have considered only soil, and the second problem we have considered only water. Now let us consider the soil and the water. Okay. So let us consider this. Now let me draw the diagram. This is ground surface, and the water table is also extended. Okay, this is ground surface, and this one, and at the level AA we have to find out, the total stress, effective stress, and the pore water pressure. So the this is BB, and the top is BB. So at BB, what is the total stress? At BB, what is the total stress? It is it is the ground surface. The water, there is no water and the soil above that one. So that how much is the total stress? The total stress is equal to 0. So the total stress is equal to 0. Pore water pressure, pore water pressure is how much? It is the top point. There is no water present above it. So the pore water pressure is also equal to, pore water pressure is also equal to 0. And the effective stress, that is equal to total stress minus the pore water pressure. So the effective stress is also equal to 0. Now, so at AA, now what is the total stress? What is the total stress at AA? Now you tell me, what is the total stress? Unit weight of the soil is gamma, and unit weight of the water is gamma W, and this depth is H. So at at AA, what is the total stress? It is gamma. No, it is gamma saturated, because the soil is underwater. So that it is gamma saturated into the gamma W. So it is how much total stress at AA? There is a weight of the total stress of the at AA means, it is the stress of the soil mass above it. Soil mass comprises of the soil grain and the water. And what is the soil mass above it? In this portion, what is the soil mass? This soil mass is the saturated soil. So the unit weight of the saturated soil we have to take into consideration. So it is gamma saturated into H. H is the total stress. Now the pore water pressure. Pore water pressure. Pore water pressure is how much? Pore water pressure means it is the pressure given by the hydrostatic pressure given by the water. Now that is that means you have to multiply the unit weight of the water by the depth. Depth is how much? Depth is H, and unit weight of the water is gamma W. So we have to find out this one. Now what is the effective stress? Effective stress is equal to how much? It is the total stress, that is the gamma W into H. It is gamma saturated gamma saturated there is a gamma total stress gamma saturated into H minus pore water pressure gamma W into H. So from that one we can find out gamma saturated minus gamma W into H. So gamma saturated minus gamma W is nothing but the gamma submerged into H. So from that one we can find out what is the effective stress. So the effective stress at the AA is the stress given by the soil grain. So what we have to do? We have to, from the total stress, we have to subtract the stress given by the water. So the stress given by the water is nothing but the gamma W into H. So from that one we can find out it is the gamma saturated into H, that is the total stress, and the gamma W into H is the pore water pressure. So from that one we can find out, and that is nothing but the gamma submerged into H. So in this way, if the soil is submerged, then we can find out the total stress, effective stress, and the total stress, pore water pressure, and the effective stress. Okay, can you understand this one? Aibo, gamma saturated. When you say the gamma saturated, it is actually, what is the gamma saturated? It is the saturated mass of the soil. Saturated mass means mass of the water and the mass of the soil grain. So the together is called the saturated weight of the soil. Gamma we have considered. So saturated weight of the soil. What is the saturated weight? It is the weight of the soil grain and the weight of the water. Together is called the saturated weight of the soil. So that is the gamma saturated means it is the saturated weight of the soil. So saturated means it is the saturated weight comprises of this weight of the soil, soil grain and the weight of the water. That's why we have considered the gamma saturated. Can you understand? Is it clear? Is it clear? Uh, Now you go. Let me draw another. Let me take the another slightly there. Now you try to tell me. Okay, all of you try to solve that one. Slightly difficult than the previous one. Now in this one, this is a ground surface. This is the location of the water table, and this is the surface, or this is the surface. Say that is A, on which we want to find out the total stress, effective stress, and the pore water pressure. Okay, so this depth is H1. This depth, this two, this is gamma saturated, and the gamma weight of the water is the gamma W. Okay, now say this is BB, and this is CC. Okay, now you try to find out the stress at the AA, BB, and the CC. That is, you have to start from the top. So you have to try to find out at the BB, you try to find out the stress at the CC, and then you try to find out the stress at the AA. So from there, so how to find out? Now let me go do it. So the total stress first at BB. Let us consider at BB. What is the total stress at the BB? BB is the top surface, so the total stress is equal to 0. What is the pore water pressure? Pore water pressure, it is also 0. And what is the this one effective stress? So the effective stress, the total stress minus the pore water pressure, so both are 0. So the effective stress is also 0. Now at CC. At CC means whatever the stress given by the soil above the CC on the CC. That means it is the stress given by the soil which is above the CC on the line CC. That means we will not consider the CC line, the unit weight of the soil at the CC line. We will consider only the unit weight of the soil which is above the CC. Now let me find out what is the total stress. What is the total stress? How much is the total stress? Yeah, gamma is the bulk density of the soil into H1. There is no water present because it is above the water table, and here we have not considered the capillary rise of the water. So the capillary rise of the water is not taken into consideration. So this portion is above the water table. So we shall consider that there is no water present over there. Only the soil grains are present over there. That means we have considered the soil as the dry soil, and the unit weight of the soil is given as the gamma. So it is gamma into H1. Then what is the pore water pressure? Pore water pressure, because in this one there is no water present, so the pore water pressure is 0. So the effective stress is how much? What is the effective stress? That is equal to gamma into H1 minus 0. So it is gamma into H1. Okay. So from that one we have to find out at the CC level it is gamma into H1. Now at AA. Now let us find out at the AA total stress. Total stress. How much at the AA? One thing, not like this. It is the weight of the soil above the water table that will give some pressure over here. There is the weight of the soil above this, within this portion, that will also give some pressure. Means the weight, whatever the weight of the soil, total soil placed above that one, that weight is the total stress acting over the point AA. That is the stress given by this one is nothing but the whatever the weight of the soil above the line AA. So that means equal to, it is the weight of the soil in this portion as well as the weight of the soil of this portion. So what is the weight of the soil of the first portion? It is gamma into H1. And what is the weight of the soil of the second portion? It is gamma saturated into H2. So that is the total stress. Can you understand? That is the, here we have to consider, what we have to consider? We have to consider the this portion of the soil as well as the this portion of the soil. This portion is the gamma into H1. That is the weight of the soil. Or this portion is the gamma into H1, and the weight of the soil for this portion is the gamma into H2. So the from gamma saturated into H2. So we have to consider like this. Now what is the pore water pressure? Pore water pressure. How much is the pore water pressure? It is gamma W into H2. Now H1 is dry. H1 is dry. There is no water present over the H1. What I told you that earlier, that the here the portion above the water table is considered as the dry. That means the capillary rise of the water is not taken into consideration. So the portion below the water table is the having the water, and the portion of the soil which is above the water table, in the voids there is no water present. That means if you take the three-phase diagram for this portion, if you draw the three-phase diagram, there is only soil solid and the air. And if we draw the three-phase diagram of this portion, then it is soil solid and the water. Can you understand? So in this portion there is no water present within the void. In this portion there is only water present within the void. No air is present within the void. So that it is gamma W into H2. Can you understand this one? Why it is H2? Why not H1? Can you understand? Can all of you understand this one? So, and the next one is the effective stress. So the effective stress is very easy. So you find out, it is the total stress, that is the gamma into H1 plus gamma saturated into H2 minus gamma W, minus gamma W into H2. So you simplify that one, and from that one you find out is the effective stress, and you try to draw the diagram also. Can you understand this one? So in this way, at the different level, we can find out what is the stress acting. We can find out the total stress, we can find out the pore water pressure, and then we can find out the what is the effective stress. So this is end of today's class. Let me stop.